6.5. We are going to start off with some review and then get into our new material. So we're going to start with reviewing the complex plane. A complex number can be written as z equals a plus bi and plotted as a comma b in the complex plane. So we did this in Algebra 2 last year, where we have the real axis and the imaginary axis. So if you wanted to plot the imaginary number 3 plus I in the complex plane, what we did is we converted this to an ordered pair. Now it's not 3 comma I, it's the A and the B. Okay, B is the coefficient of I. So it's 3 comma 1. Now we don't put 3 comma 1. It is labeled 3 plus I. And if I wanted, let's say, negative 2 minus I, this would be negative 2, negative 1. So you go left 2, down 1. And that's the complex number there. You guys remember this from last year? Pretty easy. All right, absolute value of a complex number. Again, we did this last year. It says the absolute value of a complex number, we'll call it z, equals a plus bi. You can either call it the absolute value of z or the absolute value of a plus bi. What I want to do is take you back to Algebra 1 a moment. Do you remember when we said, okay, what's the absolute value of negative 5? What is that? It's 5. Geometrically, though, what does absolute value of a number mean? The distance on a number line to 0. And distance is always non-negative. So now we're going to make a connection, and I think you can see the connection to the vectors here. If I want to know the absolute value, say, of 3 plus I actually am really being asked, and so, this isn't a vector, but I'm just so tempted to make it a vector, that I'm talking about the distance from the origin in the two-dimensional space to 3 plus I. Well, how do you find that distance? I can drop a perpendicular, and the hypotenuse, this is a right triangle. So the absolute value of 3 plus I is the square root of 10. So I really don't want you to memorize this at all. I would like you to think about it. If you want the absolute value of a complex number, it's more important to me that you reason out, all right, absolute value means distance from 0 on a number line, if it's just a single number. But if I'm in 2 dimensions, it's that absolute value of that 2-dimensional number is how far am I from the origin. And you can always drop a perpendicular and do Pythagorean theorem. Does that make sense? Let's do example 1 then. So if it says plot z is negative 2 plus 5i, so we're going to do that first, and find its absolute value. You don't have to write it as an ordered pair. That helps me. notice this is not an XY grid. This is a real imaginary grid. It's the complex plane. So here's the point. Again, we do not write down -2, 5, because that is not true. It's the imaginary number, -2 plus 5i. So you choose how you want to do this. If I want the absolute value, I can drop the perpendicular. So the absolute value is the square root of -2 squared plus 5 squared. Notice I does not go into the radical. We're always doing a squared plus b squared. Once in a while I'll have a student pop I in there. Pop I, get it?
Like the chicken. Or the Sailor Moon Man.
Okay. All right, now we're going to do some new stuff. Trigonometric form of a complex number. Okay, I'll give you a moment. I was blocking your view. All right, trigonometric form of a complex number, we'll call it z equals a plus bi, is z equals r times the quantity cosine theta plus I sine theta. So that should look a little familiar to us. Remember in the previous lesson on vectors, what was in the place of r? The magnitude of the vector. Is that not the same thing as the absolute value? Oh, connection. We also know something from our unit circle, that a is like the x coordinate is r cosine theta. B is like the y coordinate. It's r sine theta. And then we already saw this. The magnitude was like the square root of a squared plus b squared. So r is the same thing. Tangent theta is b over a. I am going to give you a formula sheet for the next quiz that has 6.5, what you need, and it'll have these kinds of things on it. So example 2 says, write the complex number z in trigonometric form. And what I think happened on our last quiz, why some of us we kind of dipped down a little bit, is sometimes when you have that index card, we don't put as much effort and energy into studying because we think, oh, I can write that down. So I'm not sure that was with everyone, but for some, I think that was the case. That you need to know, even though I'm going to give you a formula sheet, that doesn't mean, oh, I'm not going to study. I should be studying. My point was this. So on the next quiz, if I give you a problem like this, if you're sitting there going, well, what's trigonometric form? Well, that's a problem then if we don't know what that is. So trigonometric form is having z equals r times cosine theta plus I sine theta. Well, how do you find r? So we need to find r. R is the square root of a squared plus b squared. Notice the b does not contain the I. B is the coefficient of I. So this will be r. I get 4 plus. Now remember, if you have -2 radical 3, and it's being squared, you either take it times itself or you use your exponent properties that says that's -2 squared, which is 4, times square root 3 being squared. So that's 4 times 3 is 12, square root 16 is 4. Now we need theta. And I know tangent theta is b over a. So this is negative 2 radical 3 over negative 2. The negatives cancel and the 2's cancel. This is a unit circle value, so I'm not going to go to my calculator. And here's where some of us had a misconception on the last quiz. If I'm plotting negative 2, comma, negative 2 radical 3, that's in the third quadrant. So I've got to remember that whatever I'm getting out of this inverse tan, that's theta prime, the reference angle, and I've got to put it in the proper quadrant. So I happen to remember from my unit circle, or my 30-60 right triangle, the tangent of 60 degrees is radical 3. So theta prime is 60. If I want it in the third quadrant, that means I'm 60 degrees away from the x-axis. So theta's 240. So now, I've done all this work. We don't want to get lost with what we're doing. Trigonometric form is r times the quantity cosine theta plus I sine. Oops. I really want to do this. I sine theta. Oh my god, I am not touching that button.
I know, it was doing it to me today.
It's possessed. Okay. There we go. So this is 4 times the cosine 240 degrees plus I sine 240 degrees. Now so this is my answer. This is trigonometric form, has an r times the quantity cosine an angle plus I sine of an angle. If you figure that out, you go back to a plus bi form, which we already started with that. So don't find yourself in this repetitive loop. Okay? Yeah.
Would it matter if you put it in radians for this one?
It would not. You can do radians or degrees. Good question. Radians or degrees. You choose. All right, now, example 3 is easy because I want to go from trigonometric form to a plus bi. All you have to do on this one is distribute. So radical 8 is 2 radical 2. And I'm going to take this times the cosine. I'll do this slowly. So I'm going to take 2 radical 2 times cosine negative pi over 3 plus 2 radical 2 times sine negative pi over 3. We'll just put the I on the side. Negative pi over 3 is a negative rotation of 60 degrees. All students take calculus. Cosine's positive down here. And I know my unit circle values, that's 1/2. Sine then would be negative radical 3 over 2. Multiplying and reducing. We do reduce all radicals, remember that. Is radical 2 minus radical 6i. So know the difference between standard form, a plus bi, and trigonometric form. This is very simple. All right, last thing that we're doing is the product and quotient of 2 complex numbers. And again, there's a formula that goes with these, and I will give you those on the next quiz, but you have to know how to use them. So this is the product and quotient of two complex numbers. Very, very simple. If z sub 1 is the first complex number, so we're going to use r sub 1 times the quantity cosine theta sub 1 plus I sine theta sub 1. And z sub 2 is r sub 2 times the quantity cosine theta sub 2 plus I sine theta sub 2. That's trigonometric form. And what's really neat, on Monday, we're going to move into polar graphing. So far we've been doing rectangular graphing, an x and y coordinate, and even the real imaginary. That's rectangular. We're going to see how you can graph things polar, which is circle-based. So I don't know if you've ever seen a polar graph before. I'll try and dig one out for you here in a moment. But the product is of z sub 1 times z sub 2. It's actually very, very simple to do. You multiply the r's and you add the angles. When you do the quotient, you divide the r's and subtract the angles, okay? So what we're going to do is example 4 says find the product of those two complex numbers. So here we go. So if I'm going to do the product, I'm going to take 2 times 8 is 16. And then it's the cosine of 2 pi over 3 plus 11 pi over 6 plus I sine 2 pi over 3 plus 11 pi over 6. And when we do the next two sections, you're going to see, like, why would you want to do that? That would be a good thing to be thinking at this point. You know, like, okay, what is this for? And you will see a nice explanation in your future. So I need to figure out how to add 2 pi over 3 and 11 pi over 6. Well, good news, the common denominator is 6. That's 15 pi over 6. So that's 5 pi over 2. Now, on the homework, you will usually be given better instructions than what I did here. If it said to you to find the product in trigonometric form, you would stop here. If it says find the product and write it in standard form a plus bi, we'll continue, and we're going to go ahead and continue. Where is 5 pi over 2? Where would I find that? That's more than one time around. Where is it?
90 degrees.
90 degrees, right? Because here's pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So, this is 16 times 0 plus 1 times I. If I distribute, that's 0 plus 16i, or just 16i. So again, the homework and the quizzes will be more clear than this. It'll say, put it in trigonometric form or standard a plus bi. So notice, I know it seems like I shouldn't leave that, but that really truly is trigonometric form. All right, example 5, last one. I'm going to give you a head start on me. Go ahead and put your final answer in a plus bi form. While you're working, just so you don't get frustrated on your homework, I would probably take a peek at the back of each problem that you've been assigned to see if they did degrees or radians. Because if they did radians and you did degrees, you might feel frustrated. Because some of their answers are decimal radians, and you're like, wait a minute, I know how to do this. Or you could just multiply out your degree answers and see it's the same. when you're done, check yours with the board. See if you got the same thing I did. Negative 3 radical 2 over 2 minus 3 radical 2 over 2